bid of $400 for the shed wiring labor is a fair starting point, assuming that all the materials are being provided. A breakdown of 5 hours for trenching and 3 hours for wiring at the specified hourly rates appears reasonable. $2.25 per square foot for a 1,200 square foot house is a reasonable starting point as well. However, this typically includes only the basic electrical system. The basic electrical system generally includes one light fixture in each habitable room, one outlet per wall in habitable rooms, one outlet per appliance in the kitchen, and wiring for a main panel and subpanels if necessary. Additional light fixtures are typically charged on a per fixture basis. The cost can vary depending on the type of fixture and the complexity of the installation. Additional outlets are also charged on a per fixture basis. Overhead service is usually included in the overall pricing as a percentage markup. This covers overhead costs such as insurance, office expenses, and administration. Underground service is typically charged at a higher rate than overhead service due to the increased labor and materials required. The price of $2.25 per square foot usually includes both rough-in and trim work. Rough-in involves installing the wiring, switches, and receptacles. Trim work includes installing covers, switch plates, and fixtures. When pricing electrical work, it is essential to have a clear understanding of the National Electrical Code, also known as the NEC. The NEC is a set of standards for safe electrical installation. Familiarity with the NEC helps ensure that electrical work is performed safely and correctly. Here are some key areas of the NEC to be aware of. Firstly, branch circuits. Secondly, conductor sizing. Thirdly, grounding and bonding. Fourthly, overcurrent protection. And fifthly, wiring methods. Branch circuits are the circuits that extend from the panel board to the electrical devices and outlets. The NEC specifies the number and type of branch circuits required for different areas of a building. Conductor sizing is the selection of the appropriate size of wire for each circuit. The NEC provides tables and guidelines for determining the correct wire size based on the amperage of the circuit and the type of insulation. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Bonding connects all metal parts of the electrical system together to ensure that they are at the same potential. Overcurrent protection is provided by circuit breakers and fuses, which protect the wiring from overheating and causing a fire. The NEC specifies the required overcurrent protection for each circuit based on the amperage of the conductors. Wiring methods refer to the different ways that electrical wiring can be installed, such as in conduit, cable, or raceways. The NEC specifies the approved wiring methods for different types of buildings and environments. Now let's look at the specific example of wiring a shed 70 feet from the power pack, feeding it with 60 amps using number 6 THWN wire in 1-inch PVC conduit. Several NEC articles are relevant here. Firstly, Article 300, wiring methods. Secondly, Article 310, conductors for general wiring. Thirdly, Article 314, outlet, device, pull, and junction boxes, conduit bodies, fittings, and manholes. Fourthly, Article 347, rigid PVC conduit. And fifthly, Article 408, switchboards, switchgear, and panel boards. Article 300 covers general requirements for wiring methods, including how to support and secure wiring, protect it from physical damage, and ensure proper installation in different environments. Article 310 provides tables and guidelines for determining the allowable ampacity of conductors. It specifies the conditions under which conductors can be used and the ampacity directing factors that may be required. Article 314 covers the requirements for boxes and conduit bodies, including their size, material, and installation. It ensures that boxes are properly sized to accommodate the number of conductors and devices they contain. Article 347 covers the requirements for rigid polyvinyl chloride conduit, including its installation, support, and use in different environments. It specifies the types of fittings and supports that are required. Article 408 covers the requirements for switchboards, switchgear, and panel boards, including their location, installation, and wiring. It ensures that panel boards are properly sized and installed to meet the needs of the electrical system. To determine if number 6 THWM wire is suitable for a 60 amp feed, you must consult NEC Table 310.16, which provides the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air and various raceways. THWM wire is typically rated for 75 degrees Celsius. According to NEC Table 310.16, number 6 THWN copper wire rated at 75 degrees Celsius has an ampacity of 55 amps. Therefore, number 6 THWN wire is not sufficient for a 60 amp feed under normal circumstances, as it is rated for only 55 amps. However, there are some exceptions and considerations that might allow it to be used in specific situations. Firstly, dating factors. Secondly, overcurrent protection limitations. Thirdly, exception for specific applications. And fourthly, conductor temperature rating. Dating factors may be required if multiple current carrying conductors are installed in the same conduit. NEC Table 310.15 cone provides adjustment factors for more than 3 current carrying conductors in a raceway or cable. If the number of conductors requires dating, the allowable ampacity of the number 6 THWN wire might be reduced below 55 amps, making it unsuitable. The overcurrent protection for a circuit must be sized to protect the conductors. According to NEC 240.4b, if the ampacity of a conductor does not correspond to a standard overcurrent device rating, the next highest standard overcurrent device rating is permitted, provided that this rating does not exceed 800 amps. However, this does not override the requirement to use appropriately sized conductors for the intended load. There might be specific applications where the load is not continuous and the actual current draw is less than 60 amps. In such cases, the number 6 THWNY might be acceptable, but this should be verified with careful load calculations and in accordance with NEC requirements. Temperature rating of the terminations at both the supply and load ends must be considered. If the terminations are only rated for 60 degrees Celsius, the allowable ampacity of the number 6 THWNY must be based on the 60 degrees Celsius column in NEC Table 310.16. which would further reduce the ampacity. In most cases, it is recommended to use number 4 THWN copper wire, which has an ampacity of 70 amps at 75 degrees Celsius, making it suitable for a 60 amp overcurrent device. Alternatively, number 6 aluminum THWN wire could be used, but it has a lower ampacity than copper, and its suitability would depend on the specific installation conditions and NEC requirements. Always consult the latest edition of the NEC and local electrical codes for specific requirements and to ensure compliance with all applicable regulations. It is also advisable to consult with a qualified electrical inspector or engineer to ensure that the electrical installation is safe and meets all applicable standards. Regarding the 1-inch PVC conduit, it is essential to ensure that it is properly sized to accommodate the number 6 THWN conductors and any other conductors that may be installed in the future. NEC Chapter 9 Table 4 provides the dimensions and percentage area of conductors and conduit. According to NEC Chapter 9, Table 4, the maximum number of number 6 THWN conductors allowed in a 1-inch PVC conduit is dependent on the conduit fill percentage. For 3 or more conductors, the maximum fill percentage is 40%. The area of number 6 THWN conductor is 0.507 square inches. The inside area of a 1-inch PVC conduit is 0.824 square inches. Therefore, the maximum number of number 6 THWN conductors allowed in a 1-inch PVC conduit is calculated as follows: 0.40 multiplied by 0.824 equals 0.3296 square inches. Divide 0.3296 by 0.507, which equals approximately 6.49. This means that you can fit a maximum of 6 number 6 THWN conductors in a 1-inch PVC conduit while adhering to the 40% fill limit. Always refer to the NEC tables for accurate conduit fill calculations and to ensure compliance with all applicable regulations. For the shed's 4-circuit panel, it is important to choose a panel that is appropriately sized for the anticipated load. A 4-circuit panel typically has a main breaker rated for 60 amps or less, depending on the specific model. Ensure that the panel is rated for the voltage and amperage of the service and that it has sufficient capacity for the number of circuits required. When installing the panel, follow the manufacturer's instructions and NEC requirements for mounting, wiring, and grounding. It is important to use the correct size and type of breakers for the panel and to label each circuit clearly. Regarding the house wiring, it is important to understand the specific requirements for each room and area. The NEC provides guidelines for the number and placement of outlets, lighting fixtures, and other electrical devices in residential buildings. In general, habitable rooms such as living rooms, bedrooms, and dining rooms should have outlets spaced no more than 12 feet apart along each wall. Kitchens and bathrooms have additional requirements for GFCI protection and dedicated circuits for appliances. Lighting fixtures should be installed in accordance with NEC requirements and local codes. It is also important to consider energy efficiency when selecting lighting fixtures and appliances. LED lighting is a popular choice due to its low energy consumption and long lifespan. When wiring a house, it is essential to use the correct size and type of conductors for each circuit. The NEC provides tables and guidelines for determining the appropriate wire size based on the amperage of the circuit and the type of insulation. It is also important to use the correct wiring methods such as non-metallic sheet cable and M cable or conduit, depending on the specific application and local codes. Grounding and bonding are critical for electrical safety. The NEC requires that all metal parts of the electrical system be properly grounded and bonded to ensure that they are at the same potential. This helps to prevent electrical shock and ensures that fault current can flow back to the source, tripping a circuit breaker or fuse. Overcurrent protection is provided by circuit breakers and fuses, which protect the wiring from overheating and causing a fire. The NEC specifies the required overcurrent protection for each circuit based on the amperage of the conductors. It is important to use the correct size and type of breakers for the panel and to label each circuit clearly. When pricing electrical work for a house, it is important to consider all of the costs involved, including labor, materials, permits, and inspections. A price of $2.25 per square foot may be a reasonable starting point, but it is important to adjust the price based on the complexity of the project, the location, and the availability of materials. Be sure to include the cost of additional fixtures, outlets, and other electrical devices in your pricing. It is also important to factor in overhead costs such as insurance, office expenses, and administration. Underground service is typically charged at a higher rate than overhead service due to the increased labor and materials required. Be clear about what is included and what is not in your pricing. Obtain all necessary permits and inspections before starting the work. Always consult the latest edition of the NEC and local electrical codes for specific requirements and to ensure compliance with all applicable regulations. It is also advisable to consult with a qualified electrical inspector or engineer to ensure that the electrical installation is safe and meets all applicable standards.